Find the exact values of the 6 trigonometric functions of the angle theta if theta is in standard position and the point P 4, -3 is on its terminal side. Let's sketch a pair of xy axes so that we can get this picture straight in our heads. We're told that the angle theta is in standard position, which means that its initial side opens in the direction of the positive x-axis. And the angle is opening up so that its terminal side is at the point, contains the point 4, -3. Now, it could actually open up in one of two directions. It could open this way, or it could open this way, but regardless of which way it opens, whether it's a positive or a negative angle, we know that the point 4, -3 is to be up on the terminal side. So if we count out to, let's say, 4 is here. I haven't really set a scale, so I can be somewhat arbitrary in that. And go down to -3, likewise, all I need is to have the general location correct there. Then this point is on the terminal side of the angle theta. Now for simplicity, we might as well assume that theta opens up in the counterclockwise direction, but we don't actually know that. All that we need to know is that this point, 4, -3, is on the terminal side of the angle, and that by definition the sine of the angle theta, whether it opens in the positive direction or the negative direction, is just equal to y divided by r, where y is the y-coordinate of a point on the terminal side of the angle, and r is the radius from the center, or from rather the origin, to the point that we've been given. Likewise, cosine of theta is x over r, tangent of theta is y over x, and the cosecant, secant, and cotangent are just the reciprocals of what I've just written. So we'll fill those in a second. First, let's find the value of r. We know that x is equal to 4, y is equal to -3. I've just taken that from the coordinates of this point, and r is found by taking the square root of x squared plus y squared, which is equal to, and that's from the distance formula, just the distance from the origin out to this point would be x squared plus y squared, and that is the square root of 4 squared plus -3 squared, which is the square root of 16 plus 9. That's the square root of 25, or just 5. So r equals 5 in this case, and we can fill in the values. Y over r is -3 over 5. X over r is 4 over 5, so the cosine and sine are given now. Tangent of theta is y over x, that is -3 over 4. And now I'll take these as a good start on my answer. To find the other 3 trig functions, I really just need the reciprocals of those. The cosecant of theta is the reciprocal of sine, that would be r over y, or 5 over -3. The secant of theta is the reciprocal of cosine, that's r divided by x, which is 5 over 4. And the cotangent of theta is the reciprocal of the tangent, that's x over y, which is 4 over -3. So the first 3 trig functions, here are the second 3 trig functions, give us all 6 trig functions associated with the angle theta whose terminal point, or terminal side, contains the point 4, -3.